Alright, integration, annihilation, we're still at it. Okay, we're doing our thing. We're just taking integrals, we're biting their faces off. Okay, then we're spitting them out. We're not even using every part of the integral. We're just biting their faces off and spitting them in the dirt. And we're stomping on the dirt. And we're picking up the dirt and we're throwing it into a bucket and we're dumping it off the cliff. We're just annihilating these things. Okay? That's how we're going to annihilate this thing. Looks like U substitution isn't going to work because I'll end up with this weird derivative, this 2x plus 2 thing. It won't cancel with this guy. Doesn't look like a trig substitution will work. Maybe partial fractions, I don't know, but that looks like it get ugly really quick. You know, let's see what we're gonna do. What are we gonna do? What are we gonna do? You know what we're gonna do? We're gonna complete the square. That's what we're gonna do. We're gonna complete the square right here. Okay. So completing the square. Remember, we take the middle. We're just gonna take the middle term of the would-be polynomial, divide it by 2, and square it. So 2 divided by 2 is 1, squared is 1. So that's all we gotta do. So we're gonna take x squared plus 2x plus 1 equals 1. Because we're gonna add 1 to both sides of this is basically what we did. That's what completing the square is. We just add something to a would-be polynomial and, you know, set it to 0, and of course we add, and then it becomes an equation, and you know, we do it on one side, you gotta do it to the other. So what do we got here? Now, whoa, look at this. Look at that. I see a factorization right there. So now we got x plus 1 minus 1 equals 0. Okay? So let's stick it in there. Let's just do it. Let's stick it in. Okay? And when you do that, you'll end up with this. dx over x plus 1 that's all still under the radical. Now it's kind of weird. But not too bad. Not too bad. Now we'll use our U substitution. U will be equal to x plus 1. Oops. Up there, and then du is just equal to 1, it's just equal to dx, so I can rewrite this one pretty dang easy, can't I? dx is equal to du, and then I got square root of u squared minus 1. What's that starting to look an awful lot like? Let me give you a little hint. Let me put absolute value bars there. Yeah. Starting to look an awful lot like inverse secant, doesn't it? Yeah, that's what I thought. Alright, and u was equal to x plus 1. I'm telling you right now, if you want to do good, you gotta get pissed off. You gotta get a take no prisoners attitude, and you gotta take the bull by the horns. You gotta take the integral by the integration symbol and toss it around and, you know, throw it up and down the street a couple times because they're not gonna do the same for you. So we're gonna annihilate more integrals. I might just annihilate this whole damn math book I got sitting next to me. Just blow it to bits. That's the attitude you need to have. All right, see you next one.